Hi guys.
What's up?
How was your day?
Not so good, I've been struggling to find clean water source nowadays. It release apa yang dia?
I agree with you. Our river is first important.
My little brother actually got food poisoning yesterday after swimming.
Yo, for real? I'm so sorry to hear that. Last month, my uncle also got a respiratory infection because of the river.
This is not good news. If this continues, we'll let the greater risks.
Yeah, I think you're right. The Batik factory waste is the main cause of pollution in our river here.
Yes, I agree.
Assalamualaikum warahmatullahi wabarakatuh. Hello honorable judges and fellow attendees. Thank you for being here today. My name is Buana Dewi and I'm here with my partner Tim.
My name is Naira Zafira and we are from Mantu KUDUS. Batik is one of Indonesian cultural heritage that is very famous in the world. The Batik industry significantly contributes to the economy by creating jobs and showcasing the richness of Indonesian art. However, despite its beauty and economic value, the Batik industry also produces a large amount of liquid waste. According to the data from Dinas Lingkungan Hidup 2024, the Batik industry generates approximately 5 million liters each day. If this remains consistent throughout the years, the total of liquid waste produced by the Batik industry is estimated around 1,825 billion liters. Additionally, this amount is expected to increase every year.
This is caused by Batik industry waste management. We still use conventional methods. Conventional methods are less effective in processing Batik waste because they cannot handle dangerous chemical, synthetic dyes, and heavy metal dissolved in water, and they are unable to handle large volumes of water efficiently. The solution is to use an integrated filter. Integrated filters are able to process Batik waste because they combine various technologies and methods, such as filtration, settling, and chemical reaction to remove harmful substances and to reduce environment pollutions.
Therefore, we created an integrated filter solution that utilizes ultrasonic rays to manage Batik.
In this occasion, we will proudly presenting our research project entitled Cf-Krosve, Innovation of Ultrasonic Sound Filter integrated with activated carbon from Coco fiber as an effort to reduce the concentration of heavy metal Kromium in the Batik industry liquid waste.
Type of our research is tools and material that we use is
This is Coco fiber. And did you know? Coconut is the primary plantation crop in Indonesia, covering a total area of 3.3 million hectares. According to data from Badan Pusat Statistik, coconut production in Indonesia reached 2.87 million tons in 2022 and increased to 2.89 million tons in 2023. In a year, Indonesia generates approximately 1.8 million tons of coconut fiber. Wow, that's very many, right? But unfortunately, the utilization of coconut fiber in Indonesia remains suboptimal. Coconut fiber has a high cellulose content of about 37.9%, which can be a good heavy metal absorbent. The hydroxyl functional group in the cellulose undergoes deprotonation and forms a bond with chromium metal ion. The synthesis process of activated charcoal from cocoa fiber begins with preparation, which involves cutting the cocoa fiber into small pieces about 2 and 3 cm. Next, cleaning them with clean water and drying them using a microwave with 8 dB power. Following the journal by Lilandis et al. 2022, the carbonization stage starts by placing the cocoa fiber in a furnace at the temperature of 400 Celsius for 2 hours. Then, the charcoal is ground using a blender. The result of carbonization process is powdered charcoal, which is variated into 2 samples, each is weighing 5 grams. In the first variation, the activated charcoal powder is activated by soaking it in a 5% sulfuric acid solution for 24 hours. In the second sample, the charcoal powder is soaked in 10% sodium hydroxide solution and stirred for 30 minutes. Both of the samples are then filtered and washed with distilled water until neutral solid are obtained. As we can see on the result after the filtration process, the sodium hydroxide sample yields light brown water, and the sulfuric acid sample yields clean water. Last, both samples are dried in an oven. The visual sampling process begins by dissolving 1 gram of chromium powder in aqueous until it reaches the 1000 ml marks on a 1000 ml flask. The final sampling process is carried out by dissolving 100 ml of the stock solution potassium perchromate in 1000 of aqueous until it reaches the 1000 ml mark, which serves as the working solution for the metal content tasting paste. Sepia 2021.
So the filtration process starts with collecting liquid waste from the Batik industry into the input box. Next, the wastewater will be pumped and flowed throughout the pipe until it passes throughout the speaker. Within approximately 1 minute, the chromium particles to move parallel carbon. The result of the filtration process from the ultrasonic sound filter will be separated into 3 parts, where the flow with the collection of chromium particles will come out throughout the middle pipe and be collected in output 1. While the filtration result that contain chromium will flow in the right and left pipes and be collected into output 2. Furthermore, to increase the efficiency of the first filtration result, the first purification result will undergo an absorption process using activated charcoal from cocoa fiber for 15 minutes. The result of the second filter will be accommodated in the final output that's supported by the edge sensor SEN0161 and turbidity sensor SEN0189.
For the charcoal that has been synthesized using sulfuric acid and sodium hydroxide in a produced crystalline structure or sharp peak. The body fraction peaks indicate that the material form predominantly has an armor-proof structure. This can also be associated with the porous nature of the material, which exhibit high microporosity and mesoporosity. The synthesis of activated charcoal is considered successful with the formation of an armor-proof structure, although with a small amount of graphene oxide or GO form. The result of the ash content and moisture content tests on both samples show that the sulfuric acid sample has a greater absorption capacity compared to the sodium hydroxide sample. This could be due to the lower water and ash content in the sulfuric acid sample compared to the sodium hydroxide sample. The less water present, the larger the pore structure and absorption value of the activated charcoal will be.
Based on the calibration test of the ultrasonic sound wave filter system using the Arduino application, an error value was obtained of 0.9% and a frequency of 30 kHz, the hand turbidity sensor always repeats measurement in every 2 seconds. From the calibration result of the turbidity sensor, the maximum measurement value was obtained with 300 NTU. The highest NTU value was obtained by sample with charcoal treatment active, NTU 154, then followed by sample treated with ultrasonic sound wave filter and activated charcoal. This is possible because as a result of charcoal texture in the form of powder particles dissolved into the sample, so the final output results are not completely clear. Total chromium content in artificial wastewater. The highest content of potassium dichromate is in a sample without treatment, and the lowest is a condition when artificial wastewater is filtered using activated charcoal and ultrasonic sound wave filter with an absorbent value between 0.2 until 0.4.
This research was conducted at KUDUS Integrated Science Olympiad Laboratory from December 2024 to February 2025. The method we use is experiment, qualitative and quantitative methods.